Good morning or afternoon, everybody. We're going to be talking about, we're going to start right triangle trig today with Sohcahtoa 2020. We have three goals today. Number one is to identify the requested trigonometric ratio. One thing I want you to remember is when they ask for the sine, cosine, or tangent of something, they're just looking for the ratio or fraction that represents it. You're not problem solving it. That is different than number two, using a trig ratio to find a missing side. And for that, we're going to use regular trig and proportional thinking. The other way is use a trigonometric ratio to find a missing angle. For that, we're going to use inverse trig, which on your calculators is simply going to involve hitting second and then moving on from there. All right, so the first thing we do is we realize the sides. Okay, so here's our right angle. We're talking about right triangles. Later in the year, we'll deal with non-right triangles. But right now, it's right angles. Hypotenuse is the same, just like the Pythagorean theorem, just like everything else. It's opposite the right angle. This is our reference angle, theta. The opposite doesn't touches it. The adjacent touches it. And then these are the ratios. Sine is opposite over hypotenuse. So the sine of that angle would be the opposite over the hypotenuse. Cosine would be the adjacent over the hypotenuse. Tangent would be the opposite over the adjacent. Out of the three, tangent is the one that could be bigger than one. Sine and cosine are always going to be greater than or equal to 0 and less than or equal to 1. Okay? Now, when they ask you to identify the requested trigonometric ratio, given a right triangle and they give you three sides, identify the requested trigonometric ratio based upon the angle they give you, all right, and the corresponding side lengths given. All right, that will hopefully be pretty straightforward for you. When they give you two sides, and that'll be the second part of this section, we're going to use good old Pythagorean theorem to find the third side when necessary, and then from there we carry out step one above. Things to remember. Things to remember. Given two non-right angles of a triangle, the sine of one angle is equal to the cosine of the other angle and vice versa. If I go back to my diagram above, the sine of this angle is equivalent or equal to the cosine of that angle. The sine of that angle is equal to the cosine of that angle. So if you use different angles, you're going to get different answers. However, when we find side lengths later, that is possible. When necessary, you must simplify fractions by either reducing or rationalizing any and all denominators. That's why we did that in the review. All right, so now some examples. Cosine of z, if you need to underline or circle your angle. Cosine is adjacent over hypotenuse. The adjacent is 40. Hypotenuse is 50, which is 4 over 5 when we reduce. Tangent of a, all right, whenever we're dealing with tangent, there's no hypotenuse. The opposite is 36. The adjacent is 15. 36 over 15 reduces down to 12 over 5. I know 3 goes into both because 3 goes into the sum of their digits. And again, tangent can be greater than 1. Don't get worried about that. Finally, sine. The sine of x is opposite over hypotenuse. The opposite is 9. All right. Hypotenuse is 41. All right. Now, examples when you're only given two sides. All right, sometimes they deal with triples. All right, for those of you that don't recall, 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. Those are Pythagorean triples. All right, those are the integer values or their multiples that can be the side lengths of a right triangle. So if I'm doing the tangent of m, tangent is opposite over adjacent. Well, if I use triples, I see the 8 and 17. What's missing? 15. So the opposite's 15. It makes the tangent 15 over 8, and I'm done. All right, now when they're not triples, 18 and 27, all right, and I want the cosine of W, so I don't know what the hypotenuse is. All right, so Pythagorean theorem, hypotenuse squared equals 18 squared plus 27 squared. 18 squared is 324. 27 squared is 729. All right. They add up to 1053. Now, that's a big number. All right, but here's the thing for those of you that have never been instructed on this. 9 goes into both 18 and 27, so that means 9 would have to go into my answer. All right, if I square that, 9 squared is 81. All right, so in other words, if I write it out the way you're traditionally seeing it, 1053, 81 is 13. So that becomes the square root of 81 times 13. Well, we know the square root of 81 is 9. Square root of 13. All right. So my final answer would be 9 root 13. Okay. So now the next up is using trig to find a missing sides. So you set up the appropriate trig ratio based upon the sides given to you. When they do not give you the hypotenuse, you know it's going to be tangent. And then you set up your tangent ratio. If the side touches the angle, then we're going to use cosine because that's the adjacent. If the side doesn't touch the angle, we use sine. All right, so if I look at number 1, is the hypotenuse involved? No. So it's got to be tangent. Tangent of 57 degrees equals the opposite, which is x, over the adjacent, which is 15. All right, how do I get rid of a division by 15? I multiply. I end up with 15 tangent 57. This, ladies and gentlemen, is the only work I need to see in tonight's homework, is the setup from the ratio. Now, when you're using a calculator, all right, mode, make sure your mode is in degrees. If it's not, all right, so you open it up and you're like, oh, goodness, it's in radians. It's okay. You're just going to scroll down to that. You're going to move over to degree, hit enter, and you're done. And then you hit second in mode, and that gets you out. So we need to do 15 tangent 57. And I get 23.09, which if I round to the nearest tenths, I get about 23.1 units. All right, so 1 down, 2 to go. If I flip it over, now the hypotenuse is involved, okay? It's the adjacent and the hypotenuse, so it's cosine, so the cosine of 43 equals 12 over x. Now, when the variable is in the denominator, feel free to use proportions by putting the trig function over 1, and then you just cross multiply. 12 equals x cosine 43. I'm trying to solve for x. How do I get rid of multiplication? Divide. Cosine 43. I go to my calculator. 12 divided by cosine 43. And I get 16.4. Okay. Now, one of the short things you can do if you don't want to do that, all right, and I'll show you when we set it up with the next one. Hypotenuse, once again, this time it's opposite, so it's sine. So the sine of 42 degrees equals 15 over x. Okay, the reason I only need to show that is because if you set up your initial ratio, variables in the denominator, you divide the side length by that. If you set up your original ratio like the first one and the variable is in the numerator, then you multiply the trig function by the side length. So if you want, if you can recognize sine 42 equals, oh, my variable's in the denominator, so I got to divide. 15 divided by sine 42. And I get 22.4. It's your call. So either way you want to do it is up to you. All right? But I do need to see that when you show your work for the homework. The last thing for this section is finding angle measures. What a surprise. Identify the correct trig ratio. Use the inverse trig functions, which is all you do is hit second first. And then plug in the ratio as a division problem. And that's the easiest way to do it. Oops, didn't scroll down. Identify the correct trig ratio and then use the inverse trig function, second button, and then plug in the ratio as a division problem to find the angle measure. All right, so here's my angle. Hypotenuse is involved, 8 is the opposite, so it's got to be sine. So the sine, and feel free to leave it as a question mark, equals 8 over 23. So the sine of the question mark equals 8 over 23. I go to my calculator. All right, I'm finding an angle, so I hit second first. That's the only difference. So I hit second, and then I hit the sine button. And then I just hit 8 divided by 23. It should show up almost like a fraction. So you do second, and then whatever trig function's involved, and then you enter it as a division problem. And I get 20.35. So the question is about 20.4 degrees. If you wanted to, you could then find that angle measure by subtracting from 90, because two angles of a right triangle always add up to 90. If I look at number 5, I got 43 and 35. Now it's adjacent. Cosine, question mark, equals 35 over 43. I go to my calculator. Second cosine button. And again, just a division problem, 35 divided by 43. And you can see I get about 35.5 degrees. Oops. I get about 35.5 degrees. Last one, number 6, and then you're off to the races. Opposite and adjacent. Oh, tangent, because the hypotenuse isn't involved. Tangent question mark equals 10 over 30. Can you reduce it? Sure, it would be 1/3. However, it's not necessary. Second tan, 1 divided by 3. Again, your choice if you want to do that or not. You'll still get the same angle measure, 18.4 degrees. All right, 18.4 degrees. There you go. All right, so you're off to the races. To start the assignment, again, the first cluster, I think there's 6 problems. You are just showing the trig ratio. That's all you got to do. And then the last section, this middle section, you're finding a side length. All I need to see, like we said, is this original trig ratio. That's all I need to see for work. This is fine if you want, so that if we're checking work, you know where you went wrong. And then the last one, same thing with the angle. I just need to see the original ratio. Best of luck, and message me with any problems.